This video will walk you through a process to pull different data from different sources into a single business intelligence reporting solution. Both the cities of Chicago and San Francisco make police report and crime data available for public consumption at the incident level. These data sets come from different sources in different cities. So what if you're not an expert at IT and you'd like to compare the two data sets quickly, efficiently, and interactively? We'll use the Open Data Bits methodology to do exactly that. Here's how we'll do it. We'll start with a review of the tools that are being used in this video, along with some basic information about the types of tools that you'll need for your own data mashups. We'll move on to a description of how to access the data, then import the data, show you how to model the data within a business intelligence solution, add the custom calculations, briefly explain how to understand the model as it pertains to the Open Data Bits methodology, and then we'll walk through a few examples of the types of visualizations that you can do with this data model once you have it built. There are many business intelligence tools available on the market today. For this demonstration, we'll be using Excel 2013 with Power Pivot and Power View due to convenience, familiarity, and cost. A standalone license can be purchased at Amazon for about $100. Everything that you'll see has been done on a Windows 8.1 laptop with 6 gigs of RAM, a 64-bit operating system, and a 2.4 gigahertz processor. So this is truly personal business intelligence that anyone can do with a few affordable resources out of the comfort of their own home. Let's move to accessing the data. From the Open Data Bits homepage at opendatabits.com, click on the link at the top for Open Data Sets. On this page, we've currently listed two different ways to find data sets that we've featured in our library. The first is on a map, where you can click on the map marker in order to see which data sets in different areas have been featured. For example, we have Chicago and San Francisco, both of which we'll be talking about today. And then down at the bottom, you'll also see a hierarchical list for which you can click on different data sets that we've featured. So let's go ahead and take a look at the San Francisco Police Department reported incidents. And then we'll also move down, and within Illinois, we'll look at the City of Chicago crimes for 2001 to present. Now for the San Francisco reported incidents page, you'll see that the first thing at the top is the data source link. Let's go ahead and open that up. And you'll see a similar link at the top for the City of Chicago crimes. Looking at the San Francisco data portal, you'll see that it's a Socrata site and that the police report data has been made available in a zip file. Within that zip file are the different CSV files containing individual years of data. We'll get to that in a little bit. Moving to the Chicago data portal, you'll see that this data is actually available in a preview mode, and you can actually take a look at what type of data is in here and what the names of the columns are and some of the different attributes that are within that data. Moving back to the City of Chicago crimes documentation at Open Data Bits, you'll see that the next heading down is for available access formats. And these are the different types of ways that you can pull the data into a business intelligence solution. So moving back to the City of Chicago data portal, you'll see that there is an OData feed. So if you wish to use the OData feed in order to pull this information into your solution, that's one method you could use. And then there are also several different file formats that you can use to actually download the data. So moving back to the documentation page, the next heading is sources and modeling. You'll see that columns highlighted in blue are derived, which means they do not exist in the source, but they can be derived from the source using transformations. And then there are also columns that are gray. And these are ones that we didn't use in the Open Data Bits modeling exercises for different reasons. Most of the time that it's not necessarily something that you'll need to be looking at in a report, and other times it's because something within the data can be derived from one of the other columns. So moving down this list, you'll see that the ID, which is the primary key for the table, isn't necessary just because it's something that you probably are not going to need to look at in a report. based upon our analysis. And then you'll also see that from the date field, you're able to derive a date key and a time key. And we'll talk a little bit more about that in a little bit. Moving further down this page, you'll see another heading for logical model. And this is where the ability to mash up data starts coming into play. So you'll see that we have the table that we're pulling in from the City of Chicago data portal, which is the City of Chicago crimes, blue box here, and you'll see it points to two other boxes, one for time and one for date. And looking at the key up here, you'll see that both are green, which means they're conformed dimensions, which means that they allow you to mash up the City of Chicago crimes data with other data sets that are also able to reference the time and date tables. So let's move over to the San Francisco reported incidents table. You'll see that there's similar documentation here on the different columns that you're pulling in that zip file that would be downloaded. Then moving down to the logical model, you'll see that the San Francisco Police Department reported incidents data can also be used to reference the conformed time and the conformed date dimension. Date and time dimensions take a little bit of know-how to build on your own. So Open Data Bits has gone ahead and built a couple that you can download for your own use in your own business intelligence models. Moving back to the Open Data Bits homepage, up at the top, you'll see that we have a link for documentation. And with the drop down at Open Data Bits tables, you'll see that we have a selection for date dimension and a selection for time dimension. Let's open each of those. Starting with the date dimension, you'll see that this documentation page shows you how the different columns within the date dimension are going to be specified when you're pulling it into the BI solution. And by clicking here, you can go ahead and download an open data spreadsheet version of a date dimension that we've made available. When you actually download it, and if you were to view it within a spreadsheet tool, it would look something like this. And you can see that there are several columns within this date dimension that we'll talk about a little bit later. Likewise, if you move to the time dimension, similar type of documentation, another link, and if you download that open data spreadsheet, you'll see that your time dimension is available, and it's in a format that can be used within a business intelligence solution. So let's move on to importing the data. So let's go ahead and pull in the City of Chicago police report data into Power Pivot for Excel. As was mentioned earlier, there are several business intelligence tools which can be used to do data mashups, but we usually choose to use Excel with Power Pivot just because it's affordable, it's accessible, and Excel is extremely familiar to people worldwide. So up at the top, you'll see that we have Power Pivot enabled. And if you go ahead and click on the Manage button, it'll take you to the Power Pivot screen. Under Other Sources, we'll move down to Text Files. And we have downloaded the Chicago Police Department data from the portal as a CSV file. So we'll go ahead and name it Chicago PD. And for the file path, we're looking for a CSV file, which is right there. We'll go ahead and open that. And you'll see that within that CSV file, there are headers and several columns of data once it pulls up here. And then we can walk through how you can actually specify what you want to pull into the business intelligence solution. So we have a preview window here. We can go ahead and expand that a little bit. And moving back to the Open Data Bits documentation page for the City of Chicago crime data, you'll see that we have these different rows for the columns that are within the data, specifying what we do and don't want to pull in. So under ID, you'll see that it is not used in the BI solution, at least in the way that we are using it. And moving down the list, there's a few other columns that are not used in the BI solution: X coordinate, Y coordinate, year, and updated on. Some people for other applications may want to use them, but for what we're doing, we didn't see a need for these particular columns. So let's move back to the import screen, and you'll see we can then unclick ID, and then we have XY year updated on and location. So we'll move to those. And we can unclick those. And just a little bit of commentary here on why we're not bringing these in. For every column of data that you bring in, the solution file gets larger. So the key is to try to minimize the columns that you're bringing in to what you need and what you're going to actually use. The location column is actually a conglomerate of latitude, longitude, and some other information that exists in other columns. And the X and Y coordinates, I believe those are used in a different type of GIS mapping application and aren't going to be needed for what we're doing. Also the year column, well, we can derive year from the date when we use this date column in order to form a key to point to our conformed date dimension. So once this is done, you can go ahead and hit finish, and you'll see that Excel with Power Pivot will start to pull that data into the Power Pivot model so that you can begin working with it. Once you've pulled the Chicago police data into Power Pivot, go ahead and do the same thing with the San Francisco police data, the Open Data Bits time dimension, and the Open Data Bits date dimension. As you can see, that's already been done here in Power Pivot, and each is represented as a separate tab down at the bottom. Let's move on to modeling the data. So now that we have all of the data pulled into the Power Pivot model, it's time to start modeling it so that it can be mashed together. Notice that the San Francisco data is only for the year 2013. That's because within the zip file that we downloaded from the data portal, there is a separate CSV file for each year's worth of data. There's a little over 100,000 rows in that data, so there's different ways to handle how you might want to bring that data in. If you have some ETL tools, you'd want to union all of it together into a single table. There's also ways to union or append the data in Excel or using different types of tools. For the purpose of this demonstration, we just went ahead and pulled in the 2013 data to keep things simple. Let's move back to the Open Data Bits documentation pages. Looking at the City of Chicago crimes 2001 to present, moving on down, you'll see that it does relate to both the date and the time dimensions. Looking at the San Francisco data, as we mentioned before, it also relates to those date and time dimensions. So looking at the instructions here for the sources and modeling, let's go ahead and start with the date column. So you can see that the date column comes from the source. It is used in the BI solution, and that the format should be date time, and that it's an attribute, not a measure or metric. So let's go ahead and look at that date column here in Power Pivot. You'll see at the top that it's actually come in as a text value, so we'll go ahead and change that to date. And once that's done updating, we'll also change the format so that it's in a date time format, as was specified on that Open Data Bits document. So you'll see that the format is a date time format, so that it'll show that way in the reports. And let's go ahead and move back to that documentation page. Next down, you'll see is a date key, which is a derived column, which means that it did not come in from the source. So this is used in the BI solution. It is of type date, and it is an attribute. You'll also see that it's a foreign key for the date dimension. If you didn't already have a copy of the date dimension in the solution, you can go to the link here at Open Data Bits to get yourself a date dimension. And then you'll see that it's also going to be hidden. And just as a note, it's derived from the date column. And here is actually a DAX formula. So if you're using Power Pivot, the DAX formulas will come in handy for actually creating calculated columns and custom calculations. So having moved back to the Power Pivot model, we'll go ahead and scroll over to the end, and we'll add a new column. And as you can see in the documentation, that new column will be the one that we just discussed, date key. And moving to the end of that particular line, you'll see the DAX code. We'll go ahead and highlight that. We'll copy it. Move back to this custom column, and we'll just go ahead and enter that code in. And when we hit enter, it will go ahead and give us a date key as a new custom column. When that column shows up, you can go ahead and change the name. Then we can go ahead and change the format from date time to just date. And it was also a hidden column. So we'll go ahead and right click and hide from client tools. The reason for this is that there will be a date available in the date dimension, which will be the preferred way to show a date because it will work with both the Chicago and the San Francisco data sets. So now go ahead and make any additional changes that you need to for the columns from the source, add additional derived columns, and go ahead and do that for the San Francisco data, the time data, and the date data as well. Once you've done that, you can go ahead and move to the diagram view. And up here, you'll be able to see the different tables as they've been pulled into the Power Pivot solution. And here's where we can start creating some relationships. So for the Chicago data that we just worked with, we created a date key. And we can go ahead and take that date key and drag it over to point at the date value within the date table. This will create a relationship, and we'll do the same thing with the time key. The San Francisco data, if we take a look quickly at the Open Data Bits documentation, within the San Francisco data, there's actually a source date and source time column that are in the correct format that they can be used as keys. So just scrolling across here, you'll see that they both link to the date and time dimension. They're foreign keys, and they can both be hidden in the solution. So moving back to the diagram view in Power Pivot, we can go ahead and take that San Francisco date value, use it as a foreign key to the date dimension, do the same thing with the time value, and you'll notice that the time key over here is a slightly darker text color, which means that the value wasn't hidden when it was built in the Power Pivot view. At this point, we have a dimensional model, and we can move on to building the calculations. Moving back to the City of Chicago crime data's Open Data Bits documentation page, let's go ahead and scroll down to the calculated columns and calculations heading. The first two are for the date key and the date time key, both of which we added already, so those are redundant. And moving down to the next one, it's for the crime count, and that's the type calculation, or that's of type calculation, and the DAX code for that is right here. So one of the things we're trying to do is allow you to cut and paste DAX code without necessarily having to be an expert at writing code. So we'll go ahead and copy that. Let's move back to the Power Pivot model, and down at the bottom is the calculation bar, and let's go ahead and paste that in. Now there's one little glitch here to be aware of, is occasionally the apostrophes will paste in at a slant, and so you just want to go ahead and fix those so they're vertical. I don't know exactly why that happens, but it'll prevent the calculation from functioning properly. And go ahead and hit enter, and at that point you'll have a count of rows for the table, which effectively is a count of incidents. Now, as far as formatting goes, let's go ahead and make this a whole number since it's a count of rows, and let's go ahead and give it some commas in order to separate it out and make it look nice. Next on the list is the arrest percentage, and basically what that's going to do is take the total number of rows for which the value of arrest is true and divide it by the total number of rows. So effectively, it should give us the number of incidents that resulted in an arrest. We'll go ahead and copy that DAX code. Let's go ahead and paste that into the calculation bar. Take care of the little apostrophe issue that we're having. Also applies to quotation marks. Hit enter. and you'll see that it shows up as a decimal value. So let's go ahead and change that to a percentage. You can just click on the percentage sign on formatting. At that point, you'll see that based upon the calculation that we entered, 29.16% of all incidents resulted in an arrest. Moving back to the documentation page, you'll see that there's a similar calculation for domestic percent. You can go ahead and add that into the solution, then do the same thing with the San Francisco data. You'll see that there is also a header for hierarchies, and for example with the San Francisco data that we're looking at here in the documentation, there's a hierarchy of category drilling down to description. Hierarchies can also be added to that model in Power Pivot. So if we move back to the diagram view, let's go ahead and add one to the time dimension table, and we can go ahead and hit this icon, and we'll just call it the time hierarchy. And for this one, we'll go ahead and select the hour as the high-level view. That'll drill down to the minute. And then minutes drill down to seconds. And that is a great example of a natural hierarchy, which means that there is always a one-to-many relationship. You can also do this with the date dimension. So you can have, for example, the year drilling down to quarter, drilling down to month, drilling down to day. You could also have a hierarchy where the year drills down to the week, drills down to the day. Additionally, on the individual San Francisco and Chicago tables, you can create hierarchies if there's some that you'd like to have within the reporting tool that you're using. So for example, on that San Francisco table, you could create a hierarchy where category drills down to description. Now, I should note that when you create a hierarchy on one of these tables, it will only work with that table. So you cannot pull in a calculation from the Chicago table and have it work with the hierarchy in the San Francisco table, because the data just doesn't work that way. The only place where hierarchies will apply to calculations for both data sets are where they're in one of these dimensions where there's a relationship between the source tables and the dimension tables. Let's move on to understanding the model. So moving back to the Power Pivot model, we are going to focus on two of the metrics, one from the Chicago dataset and one from the San Francisco dataset. Here in the Chicago dataset, you'll see the Chicago crime count, and here in the San Francisco dataset, you'll see SFPD count. So let's go ahead and create a new pivot table in Excel. And once we've done this, we can show the field list, and we'll be able to see the model that we created in Power Pivot. So let's go ahead and bring in those two metrics. We have Chicago crime count, and then we also have the SFPD incident count. Once we've done this, we can go ahead and add a filter just to show how the model works. So we've created a hierarchy for the date calendar. We'll go ahead and add that to the filter. And we will then select the year 2013. And then you can see that the San Francisco data set, which is only for the year 2013, can then be compared to the Chicago data set for the year 2013. Now let's go ahead and drag that hierarchy down onto rows in that pivot table. Now you'll see that the hierarchy is slicing the data set from Chicago and slicing the data set from San Francisco by year with the ability to drill down. So because Chicago has 12 years of data, it goes all the way back to 2001, and the San Francisco CSV file that we brought in only had 1 year of data. So you can see that both values are displayed simultaneously for that line item. If we go ahead and drill down into 2013, you can see the values by quarter. You can also drill down by month, and you can also then drill down by day, so on and so forth. The same exact principle would apply if we brought in time. So within the time hierarchy, if we bring that in on rows, you can see by hour of the day on a 24-hour clock when things are happening. If you put this on a graph, you'll be able to track trends by time of day, and within that hour, drill down by the minute and drill down from the second based upon when that entry was entered into the database. I'm rather skeptical that the minutes and seconds are actually representative of when things were happening, but it's probably when a computer entry was made for each individual row of information. So what we've shown here is how you can mash up both the Chicago and San Francisco data into a single business intelligence solution, and based upon the fact that they both have date and time data within those data sets, begin to create pivot charts and different types of visualizations that display the data side by side. Now let's wrap things up with some examples of data visualizations. So here in Excel 2013, we are visualizing the Power Pivot data mashup that we built using Chicago and San Francisco data. Off to the left, you can see slicers that will filter both the Chicago and the San Francisco data. The first one being year, which is set to 2013. The next quarter year, if you wanted to view only quarter one of 2013, you could select that value, and as you saw, it filtered everything on the page. If you wanted to view just the first two quarters, you can multi-select, and that'll also filter the data. Moving on to the bottom two slicers, looking at Chicago primary type and San Francisco Police Department category. Now, these two categories are very similar, yet there are differences within them, and it is possible to basically union these two values into a separate conform dimension so that you have only one slicer. But because building these reports, we weren't very comfortable with understanding the differences between the two different classifications, we thought it would be better to leave them separate so as not to cause any confusion. So for example, if you wanted to filter the Chicago data for burglary, you could click on that value and then also select the San Francisco value of burglary, and you'll see that all of the data on the page is filtered for those two values. So in the middle here, you're looking at the counts by quarter. You could open up quarter 4 and see the months. You could open up October 2013 and see the individual days. In the upper right, it's looking at count by hour of the day. And in the bottom right, it's looking at count by day of the week. So you can see that there's some fairly consistent patterns here for burglaries. If we wanted to look, for example, at arson, we could switch over to that value. And then you'll see that the two patterns between the two cities are actually somewhat similar. Even though they're in completely different parts of the country, arson seemed to be reported around the same hours of the day. And day of the week, there's some similarities also, although not nearly as strong as what you see with the hour of the day. And then you can also move to other types of values, such as assault. Then you'll see once again that there's some similar patterns going on throughout the hours of the day, and day of the week are both pretty consistent. Another visualization tool in Excel 2013 that can hook up to the Power Pivot data model is Power View. So here in Power View, you'll see similar slicers on the left-hand side with the addition of weekend, which allows the data sets to be filtered by whether or not the reports happened on a weekend versus a weekday. So we'll filter that to yes. You'll notice that on both the Chicago map and the San Francisco map that there are too many samples to simultaneously display all of the values on the map at the same time. So we'll have to filter things down a little bit further. Let's select assault for both data sets, for both Chicago, and then also we'll select that for San Francisco. Then in the middle, you'll see how many happened at each location in the AM versus the PM. So if you wanted to focus in just on the AM, you could double click on that value, and then you could take a look at how the trends differ by hour of the day. Also over on the maps, you'll notice that they're color coded, and in the Chicago data set, they're color coded by Chicago district, and in the San Francisco data set, they're color coded by PD district. Whether these are similar types of groupings or not, we're not sure, but it makes for an interesting visualization and perhaps could be useful if in fact they do represent the same type of division of geography. So in summary, using the Open Data Bits methodology and the documentation provided at opendatabits.com, you can mash up data from different sources in a matter of hours and build interactive reports that should provide value and perhaps could give you the answers that you're looking for when comparing data from different places. So for this example, we took City of Chicago crime data and San Francisco Police Department reported incident data, and we mashed it up into one data model using Power Pivot, and then we were able to create reports that compare the two data sets. So moving forward, using this methodology with different types of open data that are available around the internet, you should be able to find the value that you're looking for. This video has been created by Open Data Bits, where we model, integrate, and visualize open data. Additional resources and future dataset documentation will be available at our website at opendatabits.com. You can also keep up with us on any updates by following our Twitter account, which is @OpenDataBits.